Welcome, friends, to another great day of learning. Today is day 10, which is going to be another successful day of learning and learning Kubernetes together. So let's get started and focus to understand by getting deeper into Kubernetes. So today we're going deeper into pods and nodes. Like the title says, viewing pods and nodes. The our objectives, the first one is learn about Kubernetes pods, learn about Kubernetes nodes, troubleshoot deployed applications. So we are going even deeper. So Kubernetes pods, okay? They say a pod is a group of one or more application containers, such as Docker, and includes storage volumes, IP address, and information about how to run them. What is a pod? Okay, one or more containers. Okay, so this could be Docker containers because not all containers are made up of Docker. Okay, Docker is not the only containerization platform. So a group of one or more containers. Okay, and this includes storage, shared storage, and this is possible through volumes. Okay, and again, if you learned about containers and Docker, you should know about volumes. Very soon I'll be doing a video having about everything that you need to know concerning Docker and containers and Docker Compose. And the same includes IP address and information about how to run them. That's what a pod is. Okay, simply a group of one or more application containers. And it means that pods run in a node. Okay, so the node is the machine. Okay, so this machine has pods, and a pod is simply one container or two containers or more than two containers. Okay, and each of them has shared storage, and this is achieved via volumes, has an IP address and information on how to run these containers. Now they're saying when you created a deployment in Modi 2, okay, this was what we learned in day 9. Okay, that's why it's important to follow systematically what we do daily. So they're saying when you created a deployment in Modi 2, Kubernetes created a pod to host your application instance. Kubernetes created a pod to host your application instance. Okay. And remember when we said kubectl get pods, we're able to see the pod. Okay. They're saying a pod is a Kubernetes abstraction. Okay. That represents a group of one or more application containers, such as Docker, and some shared resources for those containers. Okay. And of course, they're just trying to re-emphasize the point. Okay. And I like this. Okay. That a pod is simply an abstraction that represents one or more application containers, such as Docker containers, and they share application resources. Now, when I go into this, they say those resources include, okay, shared storage, such as volumes, okay, networking, such as an IP, a unique, as networking as a unique cluster IP address, okay. They're saying information how to run each container, such as the container image version and the specific ports to use, okay. This is exactly what they told us up here, okay. They're emphasizing it. What resources? Networking information, okay, such as a unique cluster IP address, okay. Then shared storage, like such as volumes and information how to run a container, okay, like the port to run a container on, and the image version. Okay, so let's continue. They're saying a pod models an application specific logical host and can contain different application containers which are relatively tightly coupled. A pod models an application specific logical host and can contain different application containers which are relatively tightly coupled. Okay, so they're saying, for example, a pod might include both the container with your Node.js app as well as a different container that feeds the data to be published by the Node.js server. Okay, So they're saying the pod can have different application containers, which are relatively tightly coupled. And they give an example saying that you can have one Node.js app, which is the first one container having a Node.js app, then a second container, okay, having another Node.js web server, which is responsible, okay, for getting data, okay. All right, so those are two containers, okay. The Node.js app, okay, and another one which is responsible, okay, for feeding data. And this makes sense because up here, if you remember, they said it's a group of one or more application containers, okay. So that makes sense, okay. That here we have two Node.js apps, okay, in the one pod, two containers in one pod. That makes sense, okay. Now, let's continue. They're saying the containers in a pod share an IP address and port space, are always co-located and co-scheduled, and run in a shared context on the same node. Okay, they are always co-located, co-scheduled, and run in a shared context on the same node. So this is what uh, they're trying now to get us deeper into the gist of the matter. Okay, now I'll continue to get deeper into this. Okay, so they share an IP address and a port space, co-located and co-scheduled, and running the same shared context on the same node. Okay, so the next paragraph says, pods are the atomic unit of the Kubernetes platform. When we create a deployment on Kubernetes, that deployment creates pods with containers inside them, as opposed to creating containers directly. Okay, this is now bringing the concept home. So like when we said kubectl create deployment, and then we give the deployment a name and pass the image, okay, they're saying that command, okay, creates a pod, okay, or creates pods, and these pods have containers inside them, okay. So there's nothing like creating a container directly. The containers are running inside pods, okay. So you're saying each pod is tied to the node where it is scheduled and remains there until termination according to restart policy or deletion, okay. So from the beginning we have been knowing that pods run in nodes, okay, but now we are getting deeper. They're trying to explain it deeper, and I'm glad, like I always tell, they repeat these things again and again to help us understand them at a very deep level and have a very deep understanding. Okay, so each pod is tied to a node where it is scheduled. So in other words, Kubernetes schedules that this pod, okay, like we learned about the kube scheduler, okay, which is responsible for assigning node pods to nodes. And the kube scheduler is one of the components of the control plane, if you remember what we learned in the first few days. Okay, so that kube scheduler assigns a pod. Okay, maybe if I can get it for you. Where is this? Components of a cluster. Just to remind ourselves, okay? Are you seeing this? Kube scheduler says looks for pods not yet bound to a node and assigns each pod to a suitable node. That's what the kube scheduler does, okay? So yeah, just a reminder, and these are part of the control plane. All right, so once in a while I might go back in time just to remind you so that you understand what is going on. Now they are saying, okay, the pod remains in the node until it is either terminated, okay, according to the restart policy, or deleted. So it says in case of a node failure, okay, if a node fails, the machine, remember a node is simply a VM, a virtual machine, or can be a physical machine. If this physical machine or virtual machine, which is called a node, fails, Then they're saying identical pods are scheduled on other available nodes in the cluster. Okay. Isn't this amazing? So let's go to this section which they are calling the pods overview. Okay. Excuse me a little bit. All right. Let's carry on. So the pods overview, we have pod 1, 2, 3, and 4. Okay, so these are 4 pods. And I see this one has an IP address 10, 10, 10, 1. This one 10, 10, 10, 2, 10, 10, 10, 3, 10, 10, 10, 4. Okay, it's the IP address. And they're saying, like they've told us a pod is simply a collection of one or more containerized applications. Okay, so this is the containerized app they're giving us. Okay, and this includes things like resources such as shared storage like a volume. Okay, networking. Okay, a shared space and information on how to run them. Okay, so this is an example of a pod. Okay, having one container. Okay, this pod 2 has one container and one volume. This pod has 2 containers, okay, and 1 volume. This pod 4 has 3 containers. It's in these green cubes, okay, are containerized apps, okay, and these are 2 volumes. So this is how it works, okay. 3 containerized apps, okay, and 2 volumes. This one, 2 containerized apps, 1 volume. 1 containerized app, 1 volume. And only 1 containerized app, no volume. So this is what a pod is. Very simple to understand. And this actually makes it even clearer. Okay? Do you get it now? So let's move on. So they're saying this statement says containers should only be scheduled together in a single pod if they are tightly coupled and need to share resources such as disk. Okay? So in other words, they should not be scheduled maybe if they should not be scheduled together if they maybe in different if they're tightly coupled, they should be probably in different pods. Okay. All right. So good. Okay. We're about to reach the practical. So they're saying new title nodes. They say a pod always runs on a node. Okay. Remember, they've said a pod is simply a collection, okay, of one or more containers. Like this one, it has 1 containers and has 1 container, 2 containers, 3 containers. Okay. But that pod can have a volume. Okay. Like these volumes, these purple things are volumes, okay, or not have a volume, okay. But this pod, any of these has to run on a node, okay. So the node is down on the machine, okay. They have to run on the machine. So they're saying a node is a worker machine in Kubernetes and may be either a virtual or physical machine, depending on the cluster. A node is a worker machine in Kubernetes and may be either a virtual or physical machine, depending on the cluster. Each node is managed by the control plane. Okay, like we already know. Okay, they're saying a node can have multiple pods, and the Kubernetes control plane automatically handles scheduling the pods across the nodes in the cluster. Remember, the control plane uses the kube scheduler, okay, to do that. This kube scheduler, okay, always remember that. Okay, so just like a pod can have multiple containers, a node can have multiple pods, and the Kubernetes control plane automatically handles scheduling the pods across the nodes in the container. The control plane's automatic scheduling takes into account the available resources on each node. Okay, so the control plane knows what pod needs to be scheduled or assigned to a particular node, and knows that this pod has a certain amount of storage. Okay, like for example, maybe if the disk space is required is maybe 10 GB and only 1 GB is remaining. So the control scheduler is smart enough to know, okay, what disk space is enough or not. Let's go ahead. They're saying every Kubernetes node runs at least, okay, kubelet, okay, and they're saying it is a process responsible for communication between the Kubernetes control plane and the node. So if you're asked, how does the control plane know if a resource on the node is enough, if resources on the node are enough? Okay, it is via the kubelet. Okay, and they're saying it manages pods and the containers running on a machine. Okay, so there has to be something that manages the node itself, the machine itself. Okay, that is the kubelet. If you go back to what we said at the beginning, okay, it's exactly what we did. You see, kubelet, when it's not about node components, they talked about kubelet. They say kubelet ensures that pods are running, including their containers. This was just a summary, okay? But now we are going deeper, okay? Before even we touch the practical, now we're going deeper into these concepts, okay? And like I always felt, it's good to revise this again and again, and I'm glad they brought it up again for us to master, okay? Now, let's go ahead. They're saying, okay, a container, I want to select this. They're saying a container runtime like Docker responsible for pulling the container image from a registry, unpacking the container, and running the application. Okay. Again, if you don't know what Docker is, very soon I'm going to release a video, okay, explaining Docker and everything you need to know about Docker and Docker images and containers and Docker compose, volumes, networking, all this stuff. Okay. So you're saying a container runtime like Docker pulls the image from a registry like Docker Hub, okay, unpacks the container and runs the application inside the pod, okay? So this is what every node has, okay? It has the kubelet, which is responsible for communication between the control plane and the node. And on that very node, it manages the pods and containers, okay? And the container runtime on every pod, okay? Meaning the container runtime on the node, okay, is the one now which is responsible for running the container image from a registry, okay, like Docker Hub. It pulls from Docker Hub, unpacks that container it has pulled, okay, and runs that application, okay. And we're going to do all this, okay, in detail. So let's understand what we're going to do, okay. That's what matters. So let's go to the nodes overview. Just like they give us a picture about the pods, okay? That a pod is simply a group of containers, okay? One, I mean a group of one. It can be referred to one like this, or two, or three, or more, okay? But each of them have what they call a shared volume. So let's look at their diagram. Sometimes working with diagrams is very cool, okay? It helps you to visualize everything. So now they're saying this is the node. Again, what is a node, guys? When you hear node, don't confuse yourself. A node is simply a machine, okay? So in case my laptop is powerful enough, it can be work as a node, okay? So we can have a number of physical machines, my machine, your machine, to create what is called a cluster, okay? So a group of these machines are called a cluster because it's a group, a collection. Cluster is a collection, okay? So, but it can be either physical or virtual, okay? Just like you read here, okay? It says a virtual or a physical machine, depending on the cluster, okay? Depending on our setup. Now, when you have this machine, okay? When you have this machine, they're saying this machine here has a number of things, okay? The first thing it has is what is called a kubelet, okay? The kubelet is one of the processes on a node which is responsible for managing the pods here, okay? All these pods and communicating with them. I mean, communicating with the control plane, okay? Then in addition to that, it has what is called the Docker a runtime. Okay, this runtime is responsible for pulling images from a container registry, an image registry, okay, unpacking that container and running them. Okay, then we have each individual pod. Okay, so a node, like you have seen, a worker machine can have a number of pods. Okay, so you see our one node here having number of pods. Okay, and each of inside these pods we have what? Containers and volumes running. You get very easy to understand. So a node is the machine. This machine has a number of pods. Okay, and what is a pod? A pod is simply a collection of containerized applications, one or more containerized applications. We should have shared storage, okay, like volumes, such as volumes, networking information, okay, information concerning how we can access it, like ports, the image versions, okay. Then each of these containerized apps, okay, is run by actually what they call the runtime, okay. Like for example, if you're having Docker engine, okay, if you're using Docker, the Docker engine would be the container runtime, and then we have the kubelet, okay, which manages all the pods and communicates with the control plane. All right, let's now get into troubleshooting. It's saying in module 2, you used kubectl command line interface. And that is true. So if you didn't see that, watch the previous stream. You'll continue to use it in module 3 to get information about deployed applications and their environments. Okay. You'll use it in module 3 to get information about deployed applications and the environment. Okay. So they're saying the most common app operations can be done with the following kubectl commands. Okay. So you're saying, and we're going to try this command. You say kubectl get for listing resources, kubectl describe. This says show detailed information about a resource. Okay. We have kubectl logs, which prints logs from a container in a pod. Kubectl exec, execute a command on a container in a pod. Okay. So list resources, show detailed information about a resource, get logs from a container in a pod, execute a command on a container in a pod. So when I move on here, they say you can use these commands to see where applications were deployed, what their current status, what their current statuses are, where they are running, in what configurations, and what their configurations are. You can use these commands to see where applications were deployed, what their statuses are, where they are running, and what their configurations are. That's what we can use these commands for. Okay. So they're saying now that we know more about our cluster components and the command line, let's explore our application. All right. So they're saying check application configuration. They're saying let's verify that the application we deployed in the previous scenario is running. We'll use the kubectl command and look for existing pods. So you say kubectl get, okay? This is for listing resources, okay? So yeah, practice is gonna make perfect, okay? So they're saying if no pods are running, please wait a couple of seconds and list the pods again. You can continue once you see one pod running. Okay, let us say kubectl get pods. Let's go to our setup. Okay, so right now, excuse me, we won't get anything running. Why? Because we need to. If I come and I say kubectl get pods, kubectl. Okay, I see in this error it says the connection to the server localhost 8080 was refused. Did you specify a right host or port? Okay, so let me clear this. I have to go, let me go to this other terminal, okay, and start minikube, okay, start the cluster. So I'll say minikube start. So see, it says restarting existing Docker container for minikube, preparing Kubernetes, verifying Kubernetes components using image CR, using image, enabled add-ons, done. It says now kubectl is configured to use minikube cluster. Now we can do that command. We can say kubectl get pods. Okay, and there we are. We have one pod running. So I can minimize this and put it side by side. Next up, they're saying, next, view what containers are inside that pod and what images are used to build those containers. We use the kubectl describe pods command. Okay, we want to see what images are used to describe the containers. Okay, and what containers are inside. Okay, so I'll say kubectl describe pods. Okay, so if I expand this, you'll see more information. If I start from up, okay, you see the name says the name of the pod, Kubernetes Bootcamp. Namespace says default. Priority, that you have information like the service account, the node it's running on. Are you seeing? The start time, just the labels, okay? The annotations is the status, there's an IP, okay? Control the container information, the image being used, the image ID, okay? So yeah, this is now information, like I said, to see the container, okay? You want they said to see what containers are inside and what images are used to build these containers. Now you can know. So you see the container ID is this, okay? The image is this. This is the image which is being used to build the container. Okay, let's continue with the documentation. They're saying we see here details about the pod's container, IP address, and the ports used, and a list of events related to the life cycle of a pod. Yeah, so let's look at the IP addresses and the ports. Where did I see IP? I saw. Are you seeing this even before we continue? Seeing volumes, the information concerning the volumes. Okay. These are information concerning the containers. Okay. Then IP. Okay. These are the IP information concerning IPs. Okay. Its status that it's running. Yeah, that's what they. Then the conditions. You see where is it? I saw conditions somewhere. Conditions. Okay. The type. Has it been initialized? Is it ready? Containers ready? Pod scheduled. Information concerning volumes. Okay, pretty interesting. As long as you take it step by step, it makes complete sense. Then they say the output of the describe subcommand is extensive and covers some concepts that we didn't explain yet. But don't worry, they will become familiar by the end of this tutorial. Okay. Good to know. Let's continue. Now they say, note, the describe subcommand can be used to get detailed information about most of the Kubernetes primitives, including nodes, pods, and deployments. The describe output is designed to be human readable, not to be scripted against. Okay, that's a good note. So we continue. They're saying show the app in the terminal. Now, they're saying recall that pods are running in an isolated private network. So we need to proxy access. We need proxy access to them so we can debug and interact with them. Okay, yes, that is correct. They're running in a private network, so we need a proxy to help us interact with them. To do this, we'll use the kubectl proxy command to run a proxy in a second terminal. So again, they're bringing back this concept, okay, which is good, which will help us reinforce our understanding of what we have already studied. Then it's saying open a new terminal window, and in that new terminal, run kubectl proxy. Okay, so I can run it here. I'll clear say kubectl proxy. Again, don't get tired of practicing this. Practice makes perfect. Let's continue. So now again, we'll get the pod name and query that pod directly through the proxy. Okay. They're saying to get the pod name and store it in the pod name environment variable. Yeah. So this is what we did yesterday. Okay. So you can simply copy all this. Okay. Because yesterday they told us there's a better way. Okay. And I think we shall be studying that tomorrow. So I'll clear this other screen and paste, hit enter. Okay. So you see the name has been echoed, the name of the pod. Okay. I like this. We're reinforcing. Okay. So don't attempt to cram this, by the way. Don't attempt to. Okay. There's actually a better way for this. Then they're saying to see the output of our application, run a curl request. Okay. So this is the curl request. You can see it is pointing HTTP localhost at this port, API, v1, namespaces, defaults, pods, the pod name, this pod name that we got from up here, then its port and proxy via the proxy. So I'll copy this and I'll paste. So you see, say hello Kubernetes bootcamp running on Kubernetes, blah, blah, blah. Okay. So they're saying the URL is the route to the API of the pod. Yes. Remember, we told that there's an HTTP API given to us. Okay. That's the only way we can have access to the pods. So API, proxy, okay, to the API. And they're saying we don't need to specify the container name because we only have one container inside the pod. That makes sense. They're saying executing commands on the container. Okay. So they're saying we can execute commands directly on the container. I want to read this again. We can execute commands directly on the container once the pod is up and running. For this, we used the exec subcommand and use the name of the pod as a parameter. Let's list the environment variables. Okay, so just before we do this command, I hope you're following along and you understand that they're trying to get through this. Okay, to explain each of these tools. Okay, we did get, we listed the resources. The resources we listed were pods. We used describe. Okay, now we're using exec to execute a command. They're just going through these commands. Okay, we listed the pods. Okay, we got detailed information about the pods. Okay, and now we are into what? Executing commands. Okay, so we have the pod name. So we want to find out what the environment variables. Okay, in the pod. So I'll do it. Okay, without copying, so that I also learn kubectl, okay? Then the command to execute. If you want to execute a command, we use exec, okay, like that, broken off from execute. Then quotes, okay, dollar, because it's a variable. And I specify the variable, which is pod name, okay. Then minus minus env, because we want to list the environment variables, okay. So kubectl exec your pod name, and then the .env. They mean the command, whatever you want to pass, okay. So it says pod name not found, which means I've made a mistake, okay. Actually, this variable here is in this other terminal, if you remember, here, okay. So I need to ensure it is also here. So to do that, I can simply get this command, copy it, okay, paste it so that it's aware in its this shell is aware about it, okay. So you see the name of the pod, okay. It is echoing what is in pod name. So now I can use the previous command that we had, okay. kubectl exec pod name, which is this one. Then we have the subcommand env, okay. So minus minus is for passing a subcommand, okay. So if I hit enter, says pod not found. Is it because of my spelling? Okay. So is it because I used single quotes and not double quotes? Let us investigate this. Okay. Let us see. Yeah. So it was because of the single quotes. Okay. Yeah. Lesson learned. What is a better way of learning than through this? So yeah, this is the list of environment variables. There's a host name. Okay. There's the Kubernetes service port, Kubernetes service port for HTTPS, Kubernetes port 433 TCP. There's this one here, the same but with prot at the end. Okay. A number, there's a log level, node version, and a home. Okay. So this is how we perform what they call them, commands, okay, using exec. Okay. So again, the syntax, okay. I want to make sure I've understood. The syntax, you say kubectl exec, okay. Then in double quotes, the pod name. In our case, the pod name is in a variable, okay. But if it's not in a variable, you can just put it directly, okay. And then minus minus env. So this is the command you now pass that you want to execute in the container. Command not found cube TCL, supposed to be CTL, like that. You see? Now I want to try something. If I say kubectl get pods, okay, I want to use this. Now, using this name here, I want to use it, okay, this long name. I'm going to copy it. Then I say kubectl. Why do I always start with T? So ctl exec, okay. Then instead of passing the variable, like this, and say pod underscore name, okay, I want to pass the actual name itself, like that, okay. Then minus minus env, and see if it works. So you see, if you understand it, you know exactly what is happening, okay. So I can either store the variable, the pod name in a variable, or I can do this. In fact, now I want to add something. Instead of doing it like this, okay, like the way probably they have done it here, okay, I can say maybe export, I can say pd as the pod name, okay, pdm equals to, okay, just like they did here, okay, pdm equals to that, okay. Then I say kubectl exec, okay, pdm minus minus env. Of course, it's a variable, it has to be in quotes. That starts with a dollar, like that. So yeah, this is how you play around with things. So do you think I'll ever forget this again? kubectl exec. Yeah, nice stuff. Nice stuff. All right, let's move on. Where were we? It's saying again, it's worth mentioning that the name of the container itself can be omitted since we have only a single container in the pod. The name of the container itself can be omitted since we have only a single container in the pod. Now it's saying next, let's start a bash session in the pod's container. Okay. So this is the command. Okay. Now first, if you've done Docker, this will not be new to you. Okay. But yeah, simply starting a bash session. Let's do that. kubectl execute. Okay. Minus ti simply means in interactive mode. Okay. Then I'll put my pdm, it is shorter and I like it. Then minus bash. There we are. Okay. I think we have our shell inside the container. Okay. We have opened a bash session inside the container. Isn't that cool? Okay. So maybe now even here I can check for the environment variable. Okay, and recognize command. I thought I would just do something like this, okay, which is okay. Let us say ls, what is inside here, okay? You can see the files, okay? You can see okay, this is the root, yeah, we're in the root at Kubernetes. Okay, let me stop flexing and continue. This is not even flexing. They say we now have an open console on the container where we run our Node.js application. The source code of the app is in the server.js file. Okay. So I think this cat will make us to see the contents of that file. So cat server.js. Okay. And this is the code. Okay. In server.js. You can even open server.js. Just make sure to see it is here. Server.js. If I say vim server.js, command vim not found. Oh, there's no vim here. I'll try vi. Command vi. Okay, there's no editor here. No problem. Okay. No problem. But at least we can use cat to see the contents. Okay. So you see they create an HTTP server. Okay. Which listens on port 8080. Okay. They have a start time, a new date. They're getting a host name. Then they are doing a console.log. For those of you who know JavaScript or Node.js, yeah, this is not hard. Okay. All right. So I'll clear. Go back. It's saying you can check that application. You can check that the application is running by running a curl command. Okay. Let's copy this. Since we're inside, okay, there's no need for a proxy. So you see it's actually running very well. Then there's a note. They're saying here we used localhost because we executed the command inside the Node.js pod. If you cannot connect to localhost 8080, check to make sure you have run the kubectl exec command and are launching the command from within the pod. Check to make sure you have run kubectl exec command and are launching the command from within the pod. To close your container connection, type exit. Okay, so if you've worked with Linux, you know this. Okay, so exit, I'm back to my machine. Isn't that interesting? Okay, that we have been able to, to have some success. So with the command that we can use to like view our pods, okay, just to summarize, okay, what we have learned today. We have gone deeper into knowing what a pod is. A pod is a group of one or more application containers, including shared storage, such as volumes. Including shared resources, such as volumes, okay, or shared storage in general. Network information, such as IP address. Information concerning how to run the containers, okay, and information such as like the image version. That's what a pod is. Then we looked at a node. A node is simply a physical machine, a virtual machine, okay, on which our pods are run. These pods on the node are managed by a service, a process called kubelet. Okay, kubelet manages the pods. And then we know that there's what is called a container runtime, which will be responsible for running these containers, okay, in the pods. And also, in addition to that, we know that when you create a deployment in Kubernetes, okay, the Kubernetes automatically assigns the pods to nodes, okay, and schedules them for you automatically, okay. When one fails, okay, another pod, even like a node fails, a pod can be reassigned to another node, okay. And we've learned about tools that can help us to debug, okay, and troubleshoot, okay. First command we've known is the get, okay. Get is used to list resources. For example, if I want to list the pods, I'll say get pods, okay. So I keep on making a mistake with kubectl like that, okay. We list the pods that we have, okay. If I want to list another resource, you can change the resource from pods to deployments, okay, like that. You get, I have listed a resource, okay. I can also, we can use kubectl describe, okay, to get detailed information about a resource. For example, I can say kubectl describe pods, okay. I get detailed information about pods, like we have seen the conditions, okay, the container information, okay, and they're saying we shall go deeper into knowing these things, okay. So maybe I can also say kubectl describe deployments, okay, and there I will get information concerning the deployments. Then the command that we learned about was the exec, okay. Kubectl exec is used to run a command inside our container. For example, I can say kubectl exec, okay, our pod name, I put it in a variable called pdm, and then I can say -env to see the environment variables, okay, inside our pod. And remember, all this, we are working with only one container. Take note of that, okay. So I can clear and again use the same command to run a bash session, okay. Okay, this does not work as expected. Did I make a mistake? Yes, actually it worked, but I was supposed to see it. I have to run it in interactive mode by saying -ti like that. And there we are in our bash container, okay. To exit, I simply type exit, okay. And then finally, since I'm done with the learning today, I'll stop my cluster by saying minikube stop, okay. So the cluster is being stopped. So again, thank you for learning with me today. Day 10, can you imagine 10 days since we began? And see you tomorrow when we learn something else again. Bye for now.